Hello everyone, I'm Amir.
And I'm Toby, and today we're going to be talking about our CSC 101 final project.
We decided to focus on fine particles in major California coastal cities.
Okay, and I'm going to start off with an overview and a project demo. Let's begin. Our project outline, our problem statement. Fine particulate matter, PM 2.5, causes harm to human respiratory health worldwide. This project aims to bring awareness to current particle levels in populated urban areas, known hotspots of this issue, and determine whether personal action or government action should be taken. How it works. Our project uses a data set, which includes PM 2.5 readings in major CA coastal areas. Class and methods. Our main city class includes calculation methods performed in our init method. Then data evaluation. It records and compares PM 2.5 readings in various coastal cities, and then it reports a .text file summarizing key information. Let's begin the project demo. This is our project. I'm going to start by heading over to the Run Configurations tab. You can see I'm inputting 0 parameters, and I'm going to run it. The console says arguments invalid, which is true because I didn't input any valid arguments. I'm going to edit them. I'm going to input just a singular date and run it. Again, it says invalid arguments because it needs a CSV file attachment in the parameters to open. If I head over to Run Configurations again and I add a CSV file, you can see it outputs a .text file. If I open that, it's the analysis of all LA PM 2.5 data, which includes averages, complete data sets, and results, along with a little message at the bottom. If I go back to Run Configurations, I can edit this parameter to take in all counties we have listed. Okay, I'll run that. And you can see that the same output text file was edited to include LA data, Mexicali data, and Sacramento County data. And there you have it.
Now I'm going to go over the object-oriented programming methods and how data is handled in this class. Alright, let's jump into the code. It all starts with the initialization in the main here. As Toby showed, things are passed in through the command line arguments, including the date first, and then as many CSV paths as one wants. There's, of course, argument handling here, and throwing errors if it doesn't match. But otherwise, it'll proceed to the generate outputs function here. Again, we check if there's CSV files, and if there are, then we open it up and begin to write to the output file. Of course, we need to handle each CSV data file and create a city class, which is the core of this program. So each city starts in the init function and opens up the CSV file using standard CSV Python handling, and it's all parsed into each line as a reading object. So the reading objects hold like the month, the day, the year, the hour, and minute, and value, just as it's seen in each CSV. So each of these are a different point in the reading. This is put into the main reading list, after which all the different operations as seen in the demo are calculated and stored in the city object. And of course, each of these has proper unit testing using our test case files. And of course, they pass with flying colors. Then, once the city repo function is called, it returns a string literal block with formatting in the format as seen in the output. So for each city, it just returns like this block using the repo. Back in the main function, the other like peripherals are added, so the header, the summaries, and all that stuff. And the output file is completed, giving you the product seen in the demo.
Okay, this is our reflection. Why this program matters. So our program converts countless PM 2.5 readings into structured, meaningful insights. It makes trend analysis more efficient and reduces the complexity of raw CSV data. It also performs automatic analysis and comparison upon initialization. It further encourages evidence-based conclusion making.
Onto the community and social impact. This converts raw data into important insights, which can highlight health risks through clear presentation of data, promoting transparency and responsible reporting of information, encouraging a fact-checking community and action in policy and social standards relating to PM 2.5 in our local communities. We hope you learned something new.
Or found reason to take action in your community.
Thank you for watching.